The James Webb Space Telescope unveiled incredible images of Deagle 2c, a cluster of stars at the extreme edge of our Milky Way. To understand how remarkable these observations are, let's look back in history. In 1994, an astronomer called Deagle identified a set of molecular clouds at the edge of the Milky Way that also show evidence of star formation. Deagle identified all 8 regions from which those classified as Deagle 1 and Deagle 2 were the most distant. To give an idea of what are discussing in here, let's look at the artist's impression of our own Milky Way. In this image, the sun will be at about 26,000 light years or 8 kiloparsecs from the center of the galaxy. And the edge of the disk of the Milky Way will be at about 58,000 light years from the center or 18 kiloparsecs. The molecular clouds observed by Deagle and showing this diagram are between 16 and 23 kiloparsecs. The observed regions by JWST, Deagle 1 and Deagle 2 are the more distant and also have a higher CO luminosity, and as inferred by Deagle, are associated with recent star formation. If we look at the original Deagle's observations, we cannot see anything inside the cloud, and this is because Deagle took them with a 1.2 millimeter wave telescope at the Harvard Smithsonian Center for Astrophysics in Massachusetts. The size of this telescope is considerably small to resolve anything inside the cloud. On the other hand, data obtained in 2009 with the Canadian Galactic Plane Survey, a project to combine radio, millimeter, and infrared surveys, resolved the H1 distribution in these 2 clouds. However, the 1 arc-minute scale of this survey is still relatively large to look inside the cloud within the gray box. A more detailed survey with a 45-meter antenna of the National Radio Observatory reveals a more integrated structure in the molecular CO in this region, as shown by the magenta color in the close-up of this cloud. However, these stars were resolved in the images taken in 2008 with the Subaru 8.2-meter telescope, a near-infrared telescope atop of the summit of the observatory in Mauna Kea, Hawaii, and operated by the National Astronomical Observatory of Japan. Although with a blurry version of the observations taken by JWST, these observations show the cluster formed by the molecular gas at the edge of our galaxy. Looking at the observations taken in an even redder type of light by the Spitzer Space Telescope, we can still discern a cluster of stars, although the blurry version, due to the limitation of this telescope, show us a little less. The impressive images taken by JWST are 10 to 80 times better than the previous near-infrared images obtained with the Subaru telescope, allowing astronomers to disentangle the cluster members from other sources. Also, the many different filters of the NIRCam and NIRI detectors in JWST further allow the team to make more detailed study of the star formation in the region, peer deep into the cluster, and even resolve young stellar objects of very low masses or luminosities. With these observations, they can also study the relative abundances of stars of various masses within the extreme outer galaxy star clusters, understanding how a particular environment can influence the different type of stars during their formation. From the current observations, astronomers also can infer that the stellar composition in the cluster within the Deagle 1 and Deagle 2 clouds are similar to that of dwarf galaxies or even our own Milky Way in its early history. Now, let's look closely at the spectacular images of Webb, which are detailed images of the Deagle Cloud 2s. Here, astronomers identify young new-formed stars and even several Class 0 candidates, which might be responsible for the outflow or jets of materials along their poles. This jet could not be seen in previous observations, but are strikingly extended over long distance, even beyond the edges of the cluster. Additionally, while scientists previously suspected a subcluster might be present within the cloud, Webb's imaging capabilities confirm its existence for the first time. Of course, astronomers can still extract much more information from these observations, which, supplemented with extra data from other observatories and in different types of light, will allow them to better explain the star formation in this cluster and what this can tell us about the star formation in the edge of our own galaxy. If you like the information in this channel, don't forget to subscribe.